Rohit ji,
Yes, ma'am.
Mr. Sharad has joined. Please make him co-host. We shall start the session in 5 minutes. Mr. Sharad, are you able to hear me?
Yes, I can.
Okay, sir. We shall start in 2-3 minutes, sir.
That's okay.
Good evening, Mr. Sharad.
Good evening, Dr. Pragati. How are you?
I'm good. How are you, sir?
I'm good, thank you.
So shall we start the session?
Yes, we can. Would you like me to turn on the camera or is it okay to have it without the
Yeah,
camera?
please switch on your camera and share your slides.
Yeah,
Rohit ji, please help Mr. Sharad.
I'll share my slide. That's okay. Um, just have to toss the screens around. Just give me 1 second. Okay, I hope you see my screen now.
Yes. Saida, please start the session.
Okay, ma'am. Am I audible?
Yes, good to go.
Good evening, everyone, and a very warm welcome to all the participants joining us today on behalf of the Agriculture Valley Research Foundation. I hope you are all doing well and are excited for today's enriching and insightful session. I'm Sedanal Zahra, Technical Secretary to the founder of AWRF, and it is truly a privilege for me to introduce our esteemed speaker for today, Mr. Sharad Khanna. Mr. Khanna is an accomplished professional with extensive experience in business operations, strategic development, leadership, and technology driven solutions. Throughout his professional journey, he has worked across diverse sectors and has consistently demonstrated excellence in innovation, communication, and organizational growth. Known for his dynamic professional outlook and passion for knowledge sharing, Mr. Khanna has built a reputation for monitoring, collaboration, and inspiring young professionals through practical insights and real world experiences. His expertise spans in areas of operational management, client engagement, professional development, and emerging technological ecosystems. What makes his journey especially inspiring is his commitment towards continuous learning and adapting to evolving professional landscapes. His experience and perspectives provide valuable guidance for students, researchers, and aspiring professionals who wish to understand the importance of leadership, innovation, and professional excellence in today's rapidly changing world. Today, we are fortunate to have him with us to share his thoughts, experiences, and valuable insights. I am certain that this session will be highly informative, interactive, and most importantly, beneficial for all of us. Before we begin, I would also like to express my sincere gratitude to our respected chairperson and founder, Dr. Prakriti Srivastava, and the entire team of Agriculture Valley Research Foundation for organizing this wonderful session and creating such meaningful learning opportunities for students and professionals alike. Now, without taking much of your valuable time, I now take the honor of inviting our distinguished speaker, Mr. Sharad Khanna, to kindly address the audience. Sir, if you would, the virtual stage is all yours. Thank you.
Thank you. Thank you all for having me here, and thank you for a lovely introduction. Just to add a few more lines, for the past decade, I've been working in drones, agriculture drones, robotics, and AI. And this is what my experience has been around, and this is what I will try to share as much as I can in today's session. And thank you, Dr. Pragati, for inviting me and having me here. So how do I present it? We just present it, and if there are any questions, would it be towards the end of the session or would it be in between the sessions?
They'll ask by end of the session. Like they'll have 15 to 20 minutes of doubt clearing session at the end.
Right. Perfect. So as we already discussed my experience, so this is what I'm going to talk about. Transforming farming through robotics and intelligence. The first point is why do we need this? So I'll jump onto the second slide and come back to this one. But why do we need technology in agriculture at the moment? So the first and the primary reason is rising global food demand. I guess every one of you know more than I do in this sector. I come from technology background, so rising global food demand, declining agriculture workforce, climate and environmental changes, efficiency and sustainability goals, shift towards smart farming. Yes, that is important. That is a resultant of why we need why we need this technological shift. Real-time data for smarter decision. That is sort of We have been working on this for the last decade or so. Now, how do we do it? So, we have reduced workforce now, as everybody knows, people been moving out from the villages all the way towards the cities to find better growth, better opportunities, and people are moving away from farming as well. So, automation is one of the key factor how we can still sustain this market and how we can still keep on growing and keep on meeting the demand of the increasing demand of food. We have to adopt for smart farming, which means, could be IoT based, which is Internet of Technology, Internet of Things based systems that sort of, for example, aerial drones, they are connected to your smart devices, and then, you just command them to try, spray the fertilizer. So the drones can autonomously do that. Also, there are, for example, tractors and other machineries that can autonomously work these days. I have some videos to show you in between, so I can take you through those videos as well. Bridging innovation in food security, yes, that's another factor. Um, how, again, coming back to the same point, due to labor shortages and other high food demand, for the environmental sustainability, we have to bring in innovation in agriculture. So when we say innovation necessarily doesn't mean technological innovation, but it means how effectively, or innovation could be how we can smartly or optimize or smartly or optimize farming in a better way. So that's innovation in farming. It could be not just technical, but anything that yields better outcome. And the scope, we already know that, everybody require farming, everybody require food. And without farming, that's sort of impossible. So that is why we need it. So we've already done this slide, and why we have to talk about this, what we're doing today. Now, adoption. We already know India, USA, Japan, and Europe. These are the four countries, or these are the four regions, I'd say, where most of the agriculture and probably most of the, I'd say, technological advanced agriculture, they're working towards it. So India is one of those, the most, we are 140 crores now. And we require these technologies to meet the demand, to fulfill the demand of our people. So India is one of those. So we've seen drone DD scheme, by Honorable Prime Minister. So we are using drones for agricultural fertilizer spray. We are using drones for crop monitoring using high spectral cameras, multispectral cameras. We are using drones for other, for example, mapping or surveillance to get the outcome, and to analyze what can we do better in terms of crop growth. We're using drones for weather monitoring, which directly or indirectly helps in agriculture and farming. USA is again using drone mapping, AI-driven analytics. Again, that's part of high spectral cameras, similar to what we guys are doing. In Japan's one of those who has been doing it before anybody else did. So, the technology is there. We are yet to adopt, and the world is adopting it. So the more we know about technology, the better it becomes. We can only adopt something once we know about it. So if we don't know about it, we cannot adopt it. So I think a partial reason of why we have this session is to maybe have that insights of what technologies are available out and how we can implement. So how does the agriculture robot work? So when we talk about automation, yes, the first thing comes into mind is robots. So robots, something that moves, they are able to take decisions, a part of AI. They are able to, machines that can move autonomously. That's basically a robot, if I put it that way. And the sensors that it uses could be cameras, sensors, GPS. We use all those data. So I come from that background. This is one of the most exciting slide for me because I come from this background and I understand how robots work and drones work. So we've been working in this field. So all the data, all the sensors, for example, the GPS, the barometer, other cameras, camera sensors and others. So we combine those data to make something useful. So robots can see with the help of cameras, they can navigate with the help of GPS autonomously, and we can then collect the data and perform something on it. And that something could be, for example, we can sense weed in the vegetation using our cameras, and using the lasers we can get rid of those weed. So that's one of the part how we can do it. And then second is outside robotics, then there is AI, artificial intelligence. How do we analyze? So we can detect the weed through cameras, but we have to analyze it first. Is it a weed or is it a plant? So that analyzation part comes through AI processing. We use multispectral camera to analyze crop health. And that to analyze that, we use AI. And the action is always precise because it uses motors, actuators, which work on certain algorithms, and they're always 100% accurate. They're robots. When we say at home as well, sometimes we say I cannot keep working 24/7, I'm not a robot. So but robots can actually do that. So robots work 24/7, precise and accurate. And the best part is the more we use it, the better it becomes. So AI exactly works like our brain. So the more information I have, the more experience I have, the better I become at my work. And that's exactly how it works. Usage of robots and drones. I'll take you through some videos before I take you through this slide. It's a YouTube video. I think I'm okay to share that, Dr. Pragati. Is that okay? Just standard YouTube videos. I'm assuming yes. So I'll just share that screen. It's on the screen. I'll just, taking out some videos. I've already done some work around it. So for example, laser weed removals, we'll have a look at. Now we saw that in action, but behind the scenes, how AI basically detects it. I had a video, but I sort of lost it somewhere. Yeah, how the AI works basically is behind the scenes. I had that video, but I think I lost it. Let me try and Google it. Yep, this one. So in this video, you'll see a small screen. This is how the AI works. So basically, with the help of cameras, we identify what is crop and what is weed. Once we know which one is weed, and that after that comes the action. Now that action could be manually, with the help of robotic arm or something, manually plucking the weed. And the second option could be using high-powered laser to just get rid of them. With this particular robot, I think it is using robotic arm to remove them. You can see that here. Maybe a little slow, ineffective, but lasers, the video that we have seen earlier, is more effective than this one. So this could be a university project that they were trying or something. I'm not 100% sure. This is the one that is more effective, more commercially available, and people are using it in different countries. And then there is this tractor that I found very effective as well. It's about a 3 minutes video, and I please have a look at this as well. It gives a little bit more insights on how farming are working with technologies in hand. So here we go.
When you start out in the spring, you work the soil, and it just smells so fresh. When you till it up, and it's just the greatest smell. When I started farming, there basically was no technology. Every tractor was driven manually. Everything was done manually. You'd be planting, you had to follow a line. If the sun was wrong, you would lose the line. Darkness, you couldn't see your marks. Moisture, you couldn't see your mark. Then you'd get squiggly rows. My name is Doug Nems. I'm a farmer from Blue Earth, Minnesota. I'm a fourth generation farmer, and I raise approximately 2,000 acres of corn and soybeans. I really never thought I would see an autonomous tractor in my farming career. For me, it was really exciting the first time I got to take the autonomous tractor to the field, swipe my phone, watch the tractor start with no one in the cab, start doing tillage, come to the end of the field, turn on the end, do the tillage just as well as I can do myself with no one in the cab. I can pull up the app, I can monitor the tractor, see how much of the field it's gotten tilled, I can check the fuel level, I can check the app to see how much of the field is left. If there was something in the field that it wasn't sure about, the tractor will stop and alert me. Is this something I can go around? Do I need to go out and remove an object from the field? The app gives me all this information so I can monitor everything very closely. On farms, labor is always a challenge. We need labor for lots and lots of hours for short periods of time. The auto steer and technology has helped reduce our labor load, which makes my life a lot easier. Autonomy will help because we will be able to put a tractor out in the field and let it run for 24 hours a day because it's not manned. But it also helps us with the weather because we can run so hard when soil conditions are fit. The thing that excites me the most about autonomy is not be locked in a tractor cab all day. It will just allow me to run my business better because I can just pay closer attention to other tasks. Now we'll be doing the jobs that we always wanted to get done but never had time to because we were in the cab all the time. Farmers are fairly traditional, but I have a feeling that once they try it, they will become very accepting of it. I think the tractor can do a better job than I can do. Autonomy, it's going to be a life changer for me.
So just a short video from John Deere doesn't mean that I'm promoting John Deere, but just the video I found good, available on YouTube, to show you guys. So yes, again, precision farming, as I said, look, the robots can do the same thing over and over again with 100% precision. And we can run them 24 hours. We don't have to worry about 8 hours, 10-hour shift, 12-hour shift, and try and find more people to do the job. So basically, we can just run them 24 because robots work on sensors. So for example, a camera can detect it during the day, but we have other sensors like sonars, IRs, and other sensor who can also effectively work during the night. So we can equip any autonomous system with those sensors to work day and night. So that's something we can always do. Soil and field mapping, I think I briefly covered that earlier, that drones are being used for not only for agriculture spray that we see a lot, but also behind the scenes they work to get the data from the field, how what is the moisture level, what is sort of the elevation, and what crop or what level of what is the weather like, what is the moisture like, and what crop would suit best in these conditions. So we use drones for all that. We generate 3D maps. We do anything that is possible with drone, anything that is possible with a flying object. So imagine there is a person sitting on the drone, and whatever that person can do, our drones can do in terms of aerial mapping. Weed and pest control, we've already seen one of the robot that we just we just saw that in the video. How we can, detect and destroy those weed from the agriculture. I'm sure there are other applications that you guys might be more aware of than I am, in terms of robots and drones. Because I come from the background where, I'm not just only working in agriculture, I'm working in technology, and one of the uses in agriculture. But if you go working in agriculture, for you, you know each and every problem in terms of agriculture, be it weed, be it, weather conditions, be it anything else. So if there are any other solutions, I am also, happy to get those problems and try and find a solution. So if there are any problems, I'd say, email me, and we may have some sort of idea that brings out that, we can generate or develop a new technology that can help in this particular situation, which has not been addressed ever since, we've been working in this field. So targeted spraying and resources, we've been talking about it. We can spray acres and acres of land, uh, which is, which is, 20 or 25 or 30 times faster than what otherwise we used to do earlier. We reduce the usage of chemical. The operational cost 100% is low. Yes, there is an upfront capex cost that does create a little buzz, but over the period of time, that proves out to be effective. Environmental impact is not that much, because these most of these drones, the aerial vehicles, they fly on batteries, and batteries does sort of justify their life automatically. If in other case, if we use fuels or any other type of kerosene based fuel, so the batteries do also justify their lifetime as well. And the spraying from the top, the spray is even, and the spray really goes towards the seed. Some Because I had this question somewhere, that how when we spray it onto the top of the crop, and does it really go into the soil as well, or even if it's required. But so when drone flies over the crop, it actually sort of, with the thrust that it generates from its propellers or its fans, if in simple language, it does sort of allow those chemicals to sort of go deep into the stem, or other language that you may use for agriculture. So if I'm using wrong vocabulary for crops, pardon me on that. I'm not from an agriculture background. I am from a tech background. So feel free to correct me if I am. And precise crop monitoring from the above. We have already spoken about it briefly. So basically, the first few slides were a summary to what I'm going to cover in this session. So multispectral image that we spoke about, that gives in-depth knowledge about the crop health. We can see from the aerial distance, we can see the crop, not actually which is just visible to the naked eyes, but with the help of multispectral cameras, we can actually see what is hidden from the naked eyes. Um, we can measure. There is a famous saying, we cannot improve something that we cannot measure. So if we can measure it, yes, then there is an avenues to improve it. So first part is, we have to identify, like, if it's healthy, or if the crop is healthy or not. And with the help of multispectral images, that's the first thing we can do. Field mapping, 3D mapping, we've already covered. We can do a lot of 3D mapping. We can, plan the drainage. We can plan how we can basically plan a field better once we have an aerial image of anything that's available, rather than creating something that's sitting onto the ground. And aerial view always gives us a better picture, and we can plan better. Real-time analytics as well. So whenever I am flying drone, let's say I have a drone that is parallelly spraying and also parallelly identifying the health of the crop. So it may be able to take that decision in real time. If we have high computing power, it may be able to take that decision in real time, whether or not do I need to spray here or not. I can, avoid the path for this particular crop. There was also another problem statement that came to me about 3 months ago is, in a particular field, sometimes some people do multiple cropping. So some of those require those spraying and while the others does not. So we also have that solution available. We can do the analytics in real time, and we can also take those decisions in real time, and it can identify where to spray and where not to spray. So this is also doable. Um, Autonomous harvesting robots. We've seen that with the help of robots, we can plug in seeds or whatever. In fact, we have seen drones now doing those harvesting, taking out, for example, the fruits. I can show you another video on YouTube for drones taking out fruits. I had that, but since this slide came up, just allow me a second. I'll Google it. Another example of AI-based detection and you can see in this video, it's not only just picking up grapes, but it's actually picking up the grapes which are ready to be picked up, not just picking up everything. And on the bottom right hand side, you can see a little screen that is actually helping to make those decisions. It's just a visual representation of how AI works, but this is actually helping it to take that decision which ones to pick. So something I think they developed in China or something. So yeah, so we have seen these robots. There are plenty of examples available. I would, suggest or request you guys to, after this session, you can go onto YouTube and try and look for different types of, robots available. There are plenty of them now, ever since this age has been a technological revolution age, and we've been doing a lot of things because of accessibility to the internet, social media, and the communication has been so easier as compared to what it used to be otherwise ages ago. So everything's been fast and reliable. So we've been able to develop more and more of technology. Sitting here, I'm able to talk to so many of you people. You can give me so many ideas, and we can instantly start working on it. And that is why one of the key reason why we've been able to develop it so fast is because of the accessibility to that information, and that information is the key. So if I am sitting here, I can make robots, but I don't know how to, what exactly to make the robots for, what is the pain point, it's good for nothing. You're good in agriculture, this is how it should be done, but you don't have that access to that technology to make it more practical. It just doesn't work. So flow of information has been a key. Oh, sorry. Just So that is how we've been. So they work 24/7. We can do 24/7 operations, labor solutions. Yes, the robots we see, they can just work 24/7, and we can just get them to work, and we can just keep them. They can just keep working. So we've again seen this video, precise weeding robots, soil analysis system, automated seeding. We've already seen the video for this. Automated seeding is, there's again a robot that is sort of moving in a planned path, and it is, seeding the ground, and we have all those systems available in the market now and being commercialized. At least you'll find at least 5 to 6 big companies doing it. Uh, yes, there are a lot of capex involved. That is why we have been a little slow. India has been a little slow in this, but we are progressively working towards it. Once we start manufacturing things in India, it will become a little bit more advantageous. Seeding and planting robots, we already done that. So these are the examples of robots. If I don't know if you get the access to these slides, you can Google these companies or the robots that these are mentioned here. So one of the examples of how they work. Crop inspection analysis, multispectral cameras, that is how, with the help of drone, we can identify the crop health, we can make the decision, we can, once we make a decision, we can obviously perform an action once we need to know what exactly is happening here. Increased efficiency, the advantages we all know, increased efficiency, precision agriculture, environmental benefits, labor solutions. So, this has been in nutshell, what we've been talking about, why we need technology in agriculture. That technology promotes efficiency, it promotes precision agriculture, it promotes environmental benefits, it promotes labor solution. So when we say labor solution, I have been a great advocate of people saying, robots are taking away jobs from people, but it's actually not taking away the jobs from people. It is actually making those people sit in a better position. So, for example, if somebody is not doing the farming, is actually monitoring those robots who's doing the farming. So, taking away those risky jobs and putting them in a better place. So that is how the technology has been helping us. Challenges, one of them we have been talking about, high initial investment, the capex itself. The capex is high, yes, but it does prove out to be cheaper as we run through it. So buying a drone for 10 lakhs, 5 lakhs, 15 lakhs may seem a little bit more expensive. But imagine if you buy one drone and serve an entire village with that drone, it will prove out to be less expensive and even more productive. So yep, high initial investment, yes, that is a challenge. Technical complexity, yes, another challenge, because for example, if you've purchased a drone for 10 lakhs, you need to learn how to fly it. So there's a technical complexity, and somebody who is been in the villages and doing farming, for them, this complexity increases exponentially. So yes, that's another disadvantage. Infrastructure requirement to fly a drone. I'm just keeping a simple example of drone. To fly a drone, we need to make sure the area is free of any high tension wires, those electrical wires and all that. Just one of the examples. Same if we are using a robot, we have to ensure there is a path that robot can drive into. Job displacement concerns, we just addressed it before this slide. I knew the slides coming, so I addressed it before it. So it not only just replaces, it's again, this says concerns. It's not about it is actually replacing it. It's actually putting those people in a better place. And this is how I would put it. Real world impact by numbers. These are some numbers that I've taken from Google. Not that I have been pitching these numbers, but I've taken these numbers from Google and I'm assuming that these numbers are correct. So it does increase. Yes, it does increase that we have seen personally. I can vouch for those numbers. Chemical reduction, yes. Market value, we already know what it is there. Labor saving, water conservation, time efficiency, yes, it is there. We've seen that in real world, and yeah, backed by Google numbers. You can Google it, and there are n number of studies available that from which you can vouch these information as well. Um, in what is going to happen in future is bright for people who are adopting technology. We have to do it. Enhanced AI integration, which means the more models. Now models means the AI works as model. So in AI, there's a terminology name as model. Model means how effective is your model or how effective is your artificially intelligent brain. So that is known as a model. So how effective the solution is. So enhanced AI models and all those will obviously increase this one. So first step is detection. So this is what we're doing now. We were doing those detection, and then we sort of implement that. So swarm robotics. So swarm robotics mean a part of the drones, a part of a part of the job can be done by the drones, where drones are not able to do it, can be done by robots on the ground. If something is not able to do by the robots, then obviously something else will come into its picture, maybe a crawling bot or something. And swarms can do a you know it again enhances. So we talk about drones now. If we have, let's say, 5 drones working, talking to each other in real time and doing the spraying, it will be more effective and even quicker. um, this is what we've been working now. So 27 to 2030, this is what going to come in agriculture. 2020, 2031 to 35, there would be fully autonomous farms. This is what we envision. This is what going to happen in the years to come. There would be a person, harvesting acres and acres of land, and then the robots doing it autonomously. And we would have a sustainable food system by 2036 or by 2040, let's say. We're still growing. We're still growing more and more food. India is sitting on top of that ladder where we, need more and more food. Um, India should India should focus on agriculture robotics, and India is actually focusing on agriculture robotics. And I'm sure with this space, we'd be the number one user of technology, not just would be the user of technology, not just user of food. So not the user of product, but the technology as well. So with this, I think I come to the last slide. Thank you for hearing me out, and I welcome you for questions if you've got any. I'll just move on to the first slide so that if you've got any questions, you can also email me. And yeah, so I would want if anybody has any questions.
Thank you so much, sir, for delivering such a wonderful and thought provoking session. Now, if anyone has any doubts or questions, the participants are welcome to open their mic or drop their questions in the chat box.
All the participants are requested to actively participate in the session. Please do ask question to Mr. Sharath, and you can unmute yourself. You can ask question directly to him if you want. Sir, there is
Uh,
a question. Yes, Aida, please ask.
So there's a question from Varudhini. She's asking, are we as a nation ready for AI? What are the challenges and advantages for India in agriculture?
So we as a nation, yes, we are ready for AI. We produce more engineers than farmers every year. So our AI infrastructure is building. We are building that AI infrastructure. Government is promoting. Promoting. Government is giving grants if you've got if your company is working in AI, and Yes, we are not behind in that race. We are just working quietly. That's the only difference. I would say, yes, we are ready.
Thank you, sir. Sir, another question is that from Yagdi, which technology would you like to suggest for small farmers and why?
Um, Look, technology, in terms of technology, so for small farmers, as I said, like we buy a drone, there's a capex involved in it. Drone cost you, let's say, 10 lakh rupees. So a small farmer may not require that drone, but imagine if this farmer buys that drone, it can not only just help him, but he can also help out other people in the same village. So in terms of technologies, once you want to yield more and more, that's when you start using this technology. uh, Meeting the global demand of food supply, that is the challenge here.
Thank you, sir. Another question from Navjot Kaur is there. He wants to know what are the robotics and drone advances application in soil science.
uh, Basically, it's look, I do not know too much about it, but what I assume it's a combination of uh, creating solutions that can give you the conditions of the soil, that can give you better interpretation of how the soil looks like, or probably what is the field, what are the crops that can grow better in the soil, and use technology like drones and robotics to do so. I'll try and Google that and see what exactly this mean.
Okay, sir. A question from Nivida is that for disease detection, what type of robotics and AI technology can be used?
Um, we just covered that in the slide. We call it multispectral camera. So what that does is basically tells you the crop health. So multispectral cameras means what they do is they use different sort of wavelengths to detect particular color decoloration, or probably the other crop healths, which is not only on the top layer but on the bottom layers as well, because these rays and multispectral rays can pass through the objects as well. So multispectral cameras for crop health detection.
Thank you, sir. A question from Prasenjit is that is a license required for adopting drones in farming, and what are the laws or regulations associated with their use in agriculture?
Yes, there are licenses required. The first license is the drone that you buy should be approved from a DGCA, which is a governing body for civil aviation. Second is the one who is flying the drone has to take a license. To get a license, it's a 5-day course that you have to do with certain organizations who are authorized to provide you that license. Once you do that 5-day course, it includes the theory and the practical, and you fly a and then on the fifth day there is a test. That test sort of qualifies you for getting a license, and then you apply for a license and you get a license, and that's how you can just fly a drone. No other license is required.
Oh, interesting. Another question from Shimran Yadav is what improvement is needed in AI based agriculture for precision farming? What are the challenges in vertical farming, especially in hilly area states like Himalayan regions, and how AI should be trained?
So AI, as I said, the more we use AI, the better it becomes. The more we use, so AI is a brain that is being developed artificially. So a 2-year-old child knows. You can compare a 2-year-old child versus a 40 years old adult. So the knowledge that a 2-year-old would have is limited as compared to 40-year-old. But AI grows a lot more faster than that. So the more information or the more data we have, the better AI becomes.
Another question is from Nandita. She wants to know the difference between autonomous tractors and the normal ones.
So autonomous tractors uses sensors. It uses basically imagine a brain sitting onto a standard tractor, computer-based tractor. Basically, as computer is making decisions, computer is looking at what's in front of them, avoiding obstacles, making turns, uh, taking making the wheels turn using the steering and all that. So autonomous means it just works on its own.
There is
this is the
Saida, I think there's
last.
one question from Mr. Ajay. He's raising hand. Let him ask.
Very good evening, sir.
Good evening, Ajay. How are
Actually,
you?
my question is how can robotic technologies support the principle of organic farming?
So look, robotic technologies not only mean we are just spraying the fertilizers. It goes beyond that. As I said, look, we can monitor the health of the crops. We can monitor the health of the soil. We can also monitor precisely when do we need to water. So if I have, for example, an IoT system installed in my fields that can accurately measure the condition of the soil, we can, whether does it require more air, does it require more water, or what does it require? So that data is important. So not it has, like, if you spraying is just a part of agriculture drones.
Okay, thank you, sir. Thank you so much.
Sir, I think this is the last question from Ishwari. How can bioinformatics be integrated with robotics and drone technology in modern agriculture for crop monitoring, disease detection, and precision farming?
So this is what we require as an engineer: more and more of information, more and more of information around crops that we feed onto our AI system, and AI system develops. AI system gets more information, more data sets, understand, for example, it's skill based. I cannot just tomorrow rock up to the field and say, okay, today I'm gonna start growing let's say any crop. I cannot just rock up. It's skill based. Now those skills comes by learning. So AI does the same thing. So information has to be fed onto the system, and so that they can start making those decisions.
Thank you so much, sir. I believe that concludes our Q&A session. So let's conclude the whole meeting if no one has any other questions to raise. So thank you so much, sir, once again for your guidance and your perspectives on the topic. Sir, there's just one more question. Let's first do that as well. From Avantika, with raising concern towards AI in the long run, how much can we rely on AI-based farming?
Yes, there are concerns around AI. There are concerns around how we can rely on AI. We have to set boundary on what AI can do and what AI should not be doing. But in terms of farming, we very much know what exactly the AI is doing at the moment. How much the decisions how far we can take that in terms of making a decision. So AI is basically, as I said, models was very key word is the model here. So if we train an AI to detect the crop health, we're not worried about any security concerns that may come around it. So yes, AI, we're still developing AI, we're still setting up those boundaries, we're still in that immature stage of making sure that it does not outgrow. Yes, there has been a lot of incidents around AI outgrowing what we intended it to do, but we're doing it. We're working on it, and we'll ensure that it does not go beyond what we intend to do with it. We can
Really?
rely on farming. Yes, we can still rely.
Thank you so much, sir. Once again, on behalf of the Agriculture Valley Research Foundation, I extend our sincere gratitude to you for taking out your valuable time and being part of this session. It was truly an honor and pleasure to host you today. I would also like to thank all the participants for joining us. Your presence and participation contributed greatly to making this interaction meaningful and successful. With this, we conclude today's session. Thank you, everyone, and have a great evening ahead. Thank you once again, sir. You may now all leave the meeting.
Thank you, everyone. See you. Bye-bye.
Thank you.
Bye.